Okay, there are mistakes that can be made with this. Remember, what we're trying to do with these level of significance is describe a population by using a sample that we have access to. If we could get everybody in a population, if we could get all the men and all the women and their GRE scores in the United States, there wouldn't be a need for doing statistics. We wouldn't need the statistic because we'd have the parameter. However, that can't happen. We're making an estimate. We're taking a guess at what we think is happening based upon our small sample that's well done that represents this larger population. The problem is there's a chance we can make a mistake. Four things can happen with this. Remember, we're saying this is the difference between a sample and a population. And how good of a job we do with that is what makes a difference. And there's four things that can happen. Two of them are good, two of them are bad. And this is about a relationship between your sample and the entire population. So if we look at this, there's what is true of the population, which we don't really know, we're making a guess, and what is true of your sample. So let's say that for the GRE scores of men and women, that the population has no difference. And in our sample, we've said that there is a difference in the GRE scores of men and women. We've said something that's true, which is not. That means we've made a mistake. This is called a type 1 error or a false positive. This is saying something that is true, which is not. That's bad. So this is called a false positive or type 1. If the population has a difference, if there really is a difference in the scores of men and women, and that's what our sample says too, that's fine. We can live with that. That's okay. So this one's just fine. If there is no difference in the scores of men and women, and when we do our sample, we say there's no difference in the scores of men and women, that's fine too. So these two events that can occur between the population and the sample are fine. The last thing that can occur is the population has a difference. There really is a difference between men's GRE scores and women's GRE scores. However, for some reason, when we did it, we said there is no difference. This is called a false negative or type 2 error. That's bad too. The type 2 is not as bad as the type 1. So down here what we've said is there is no difference when in fact there was. The other way to look at this example is it's kind of like the justice system. If somebody's on trial for murder and we convict an innocent person of a crime they didn't really commit, we've said something which is true, that is true, which in fact is not. We've made a false statement about an innocent person and they can be punished for that. We don't like that. That's bad. It's also bad to not convict the guilty person. So, for example, if we have somebody on trial and the person really did it, but we failed to convict them of that, if we've failed to say something's true, which in fact it really is, that's a false negative. That's bad also. It's worse to convict the wrong person than it is to let the guilty person go free. That's why a type 1 error is the worst type of error to commit. A few other closing comments. We either reject the null or fail to reject the null. If we conclude do not reject the null hypothesis, does not necessarily mean the null hypothesis is true. It only suggests there's not enough evidence to reject it. We've just not done a good job with our sampling or something like that to reject the null hypothesis. So it may be if we were to do it again with a different sample, we maybe get a different result. But when we set our significant levels at that 0.05, we're trying to make sure that we're not making a mistake, that we're not saying something is true which is not. Last couple of things, these are the most frequently asked questions about this. How do we know what the population parameter is? We don't. If we really knew all the GRE scores of men and all the GRE scores of women, we wouldn't need to do any of this. We don't. We're using a statistic from a small sample to represent a population. Second question that's most commonly asked is, what if I'm close on the significance? Being close on significance is like being almost pregnant. It can't happen. Either it's significant or it's not. Now, once it's significant, yes, you can have degrees of significance. As I said, you can go to a 0.01, a 0.001, and be more sure about your results. But overall, either it's significant at 0.05 or it's not. If it's 0.051, that's not significant. Close is not good enough.